Hello. So yesterday we looked at the equation of a circle. So this is the general form for an equation of a circle with a center at AB, so this center there at coordinates AB, and with a radius of R. So this was our general equation, which denotes a circle. So today let's actually expand the brackets and see what happens when we actually expand the brackets here. So we've got x minus 4 all squared. That's just going to be, let's just write this out in full. So x minus a times by x minus a, and then plus y minus b times y minus b is equal to r squared. Okay, so now if we just expand the brackets, so firstly we get x squared, because x times x is x squared. We then get x times minus a, x times minus a again, so that's minus 2ax, and then we get a times, well, negative a times negative a, which is positive a squared. And a similar thing over here as well, so we get a y squared there, a minus 2by there, and a plus b squared there equals r squared. And so therefore we get x squared minus 2ax plus y squared minus 2by, plus these constant numbers here, so plus the a squared plus the b squared. And then if I just take away the r squared from both sides, we get this, take away r squared equals 0. Okay, so I can also write this in a different way as well. I mean, if we just call this number there, I don't know, let's just call it capital A. Let's call this number here, this minus 2b, capital B, and let's call this constant over there, capital C. So what we get then is we get a squared minus a, capital A, lots of x. Actually, I'm going to say plus. I'm calling this negative 2a plus positive, sorry, plus capital A. Let's just call that plus capital A. So we've got plus capital A there, but it doesn't really matter. Then plus y squared. Again, I'll call this negative 2b a positive capital B. So plus capital BX, and then plus this constant at the end, C, is equal to 0. So another way in which you can write the equation of a circle is exactly this here. So this is exactly equivalent to this up there. So basically the key point is that another form for an equation of a circle is this equation here. So that's another way in which you can write the equation of a circle. Now the key thing is that we're going to get questions where we're going to have to convert this equation into the equation we had before, like this x minus a number, I'll just call it capital A this time, plus y minus a number, I'll call that a capital B, all squared equals to r squared. We're going to have to convert this first equation into this. We're going to get questions where we're going to have to convert the first equation into the second equation, and that's exactly what we're going to do here. So let's consider this equation here. So we've got x squared plus 4x plus y squared, take away 10x plus 2 equals 0. So first question is, what is the name of this curve? And then the next question is to calculate the center and the radius of the curve. Okay, so question number one then, what is the name of the curve? This is a circle. So this is certainly a circle because it's in this general form that we want. It's in this form here. So these two forms are exactly the same. Or they're equivalent, I should say. Okay, so that's the first part done. How about this second part then? To calculate the center and the radius of the curve. Okay, so we've got this equation here. What I've just done here is actually just take away this 2 from both sides of the equation. So we get x squared plus 4x plus y squared, take away 10x equals minus 2. Okay, so how are we going to get this equation into this kind of squared format here, where you've got x and a number all squared, plus y and a number all squared? How are we going to do that? So the technique that we're going to need is completing the square. So we need to complete the square. So complete the square. And actually, we're going to need to do it twice. We need to do it with the y variables. So complete the square twice. Once with the x variables, and once with the y variables. So once with the y variables. Okay, so that's what we're going to do. Completing the square with this part here, I'll call this part 1, and this part here, I'll call this part 2. Okay, so yeah, so sorry, I've gone too far. Okay, so let's just make the writing more smaller so we can actually keep on the same page. Okay, so if we complete the square with this x squared plus 4x, so again, it's always the same technique. We're gonna put an x in there, half the coefficient of x there, which is 4, half 4, you get 2. Square all that, and then subtract the square of this constant here. So subtract 2 squared, and then do the same thing with completing the square with these y variables. So again, a y in there, half your coefficient there, so half 10, you get 5. Square that, and then subtract the square of this constant here. So subtract 5 squared, and this is equal to -2. Okay, so we get that. And then so we've got x plus 2 all squared, subtract 4 plus y minus 5 all squared, subtract 25 equals -2. We can now add these constants to both sides, this 4 and this minus 20, this 25 to both sides. So therefore we get x plus 2 all squared plus y minus 5 all squared is equal to, so 4 plus 25, that would be 29, take away 2, 27, so this equals 27. So what is our center? So therefore our center of the circle is going to be, so the opposite of this number there, so -2. So remember, again, because of the graph transformations, you actually want the opposite sign of this value there. So center at -2 and at +5. So again, the opposite sign of this number there. So because of the way that we do the graph transformation from the origin center, from the circle with the center at the origin to the circle at the center of AB. That's our transformation. And our radius, so remember, this constant at the end is the radius squared. So our radius is actually going to be the square root of 27. So that would be our two answers to the question there. Center at -2 and 5, radius of root 27. So that's exactly how you would answer a question like this. So in general, then, let's generalize what we have then. So let's say you've got a circle with this equation here. It can be written in this form here, and that's because when we complete the square, half the coefficient there, this a there, x plus half a all square, take away this number square, which is a squared over 4. Same process with the y's here. Take away the c from both sides, you get a -c there. So then again, if we just simplify this, we get x plus a over 2 all squared plus y plus b over 2 all squared is equal to a squared plus b squared over 4 subtract c, just by adding this to both sides and adding this to both sides. So therefore, this is the equation of a circle, provided, well, obviously provided that this number here is bigger than 0. Let's just make a note of this. So we want a squared plus b squared over 4 to be a bigger number than c, because otherwise, yeah, this would be negative, and we have to have a positive radius, obviously. So the key thing is to make sure that this fact here is true. And so long as this fact here is true, then you've got, yeah, a circle with a radius of the square root of this number here. So the square root of this a squared plus b squared over 4 subtract c, and a center at these coordinates here. So again, the negative of these constants there. So negative a over 2 and negative b over 2 would be our center there. So yeah, that's the key thing really to bear in mind from today's video. So you just want to make sure that you just want to make sure essentially that if you can convert equations like this into equations in this completed the square form, and you can go the other way as well. So that's just what you need to bear in mind with these circle equations.